Not only am I going to show you how to create a robust internationalization system for your application that works in any framework or even just plain JavaScript, but I'm also going to show you how to create a locale picker to swap between them. I'm going to show you how you can automatically detect the user's locale so you can show them the correct text to start with. I'm also going to show you how to make this entirely type safe, not only when you use your locales. So for example, here, I only get the specific values of developer or runner, which are my enumerations. If I try to pass in a string here, I get an error and so on. But I'm also going to show you how to make it type safe when you define your translations as well. So for example, here I have full type safety and I have autocomplete on every single thing that I would want to do. And that's something I've not seen in any internationalization library out there. I'm going to show you exactly how every bit of code inside this project works for handling things like strings, dates, pluralization, enumerizations, list, missing translations, fallback translations, and I'm going to show you how to integrate it inside of React specifically. But again, like I said, this works in any framework or library you want, and it's entirely from scratch. Lastly, I'm going to show you all the amazing internationalization features built directly into JavaScript because there's so many of them that creating a library and a function like this is actually quite easy using all these amazing built-in features. Welcome back to Web Dev Simplified. My name is Kyle, and my job is to simplify the web for you so you can start building your dream project sooner. And this library is actually incredibly small footprinted. For example, we only have 3 things that we export from our library that are usable outside of it. We have this DT function for defining a translation. That's what we use in our translation files for that autocomplete and type safety for specific translations. We also have our initialization function that initializes our code for us. And then we have this single type that we export, which is again used when we create our actual definition files to give us a little bit of extra type safety. Other than that though, this is really all there is inside of this entire project. It's a rather simple footprint, but there's a lot of stuff that goes on inside of it. So to get started, I first want to show you how this library is used that we're going to be creating, and then we'll dive into the actual integration of all the things and how it works behind the scenes. So I created an implementation for React, but it's so simple to use this, you can put it inside of any framework that you want. All you need to do is call this init i18n function. And to pass into this function, you just need a few things. As you can see here, we have our locale, we have our fallback locale, and then we have our translations. And if we go inside this function and we look, that's the literally only things that we can pass inside of it. So the locale is going to be what language your user is in. Do they want to see your application in English, Spanish, some other language, whatever it is, this is going to be the locale your user wants to access the site in. Then we have fallback locale, which can either be a string or it can be an array. If we go back here to where we're actually using this particular thing right here, you can see that I pass in English as my fallback locale. You can pass in just English on its own like this if you have just one single value, or if you wanted to pass an array, for example, I could have English and Spanish as my fallbacks if I wanted to. And this is what happens if we're missing a key. For example, here you can see we're missing a translation in English or in Spanish. If I swap to Spanish, you can see it just falls back to the English version since I don't have a Spanish version for that particular tag. Then the last thing we do is we just import all of our different translations. So you can see here we have our English translation, our Spanish translation, and then we have our English translation specifically for the US because there's different dialects. For example, in the UK, they use different words for things than they do in the US. And same thing here, we have the Spain version of Spanish. So depending on your different actual region you're in, you may have specific words you use that are different between other regions. So there's that extra level of layers that we need to take into account. For example, if we don't have a value in the US version, we'll fall back to the generic English version instead. When you call this particular function inside of here, all it's going to do is return to you essentially this function right here, which is called t. This function gets returned, as you can see, and all it does is we call this to translate things inside of our application. So if we go to our application, we look at our page, you can see we're calling t and we're passing it in whatever the name of our translation is. And you can see here, I get full autocomplete for all my different keys that I want to use. And then if I have different parameters, I also get autocomplete for that. For example, here, if I type in name, you can see I get that autocomplete showing up and it makes sure everything's type safe. And of course, if I forget to pass this in, you can see I get errors. So everything is type safe all the way throughout. And the really nice thing is if I swap my locale here with this little picker, you can see it's changing around what all my different translations are. And you can see right here, this ENUS is essentially a translation for this locale field right here, where all I'm doing is just putting whatever the locale is. And you can see in this US English version, I only have one translation defined, but since it's like a dialect of English, it's falling back to the generic English version for all the keys that it can't find. Even if I change inside of here my fallback to be Spanish, for example, you can still see when I have the US English version set, it falls back to the English translations instead of the Spanish translations because it's giving me essentially the less specific version of English. Now let me change that back to have a fallback of English for the rest of our application, and now we can actually start diving into how the actual code itself works, because building out a library like this may seem really complex, but it's actually rather simple with the concepts that are built into JavaScript. The hard part is the TypeScript around it that makes all the type safety work for us. So let's go go ahead and actually look at the code files that we have. You can see this lib folder right here. We have essentially 4 different files being defined. The easiest one is going to be this my translations file, and this is a .d.ts file. So all it is register or creating this interface called register. And this is what is used by the person consuming our library to be able to say what their specific types are. And that's what gives them their super type safety. If you looked at the video where I created my very own router inside of React, we did something very similar to this. I'll link that video in the cards and description for you if you want to check it out. But if we go ahead and we look in this main folder here, you can see we're declaring a module that points directly to that my translations file right here. So if I was importing this library from npm, all I would do is point to whatever particular file they declare that module inside of. And then all you do is you create your thing, you call interface register, and you put your translations on there, which are the type of our translations. And our translations here is just going to be, if we scroll up to the top, our English translation. So you can see we're taking our English translation and we're using that as our base for all of our translations. Now, since there's multiple different translation files, you can choose any one you want, but in our particular application, we know the English version is the most filled out version of our translation, so we want to use this as our base because it has all of the particular keys for our translations. And for example, Spanish is missing some keys because we haven't gotten around to creating them yet. Oftentimes when you're translating an application, you have one primary language is what you'll want to use when you're actually setting up that translation as your module right here. And all this does is hook up all the TypeScript magic behind the scenes for us. Now, if we open this back up, we can look at the index file because this one's really simple. All it does is export the specific things we want inside of our library to be used outside of it. So these are just those 3 particular things, those 2 functions and that 1 type. Those are the only things that are used outside of our particular library. Everything else is used internally inside of our library. The other 2 files we have are our init file, which contains our init function. If we scroll up, we have our init function, and then we have our define translation function, which if we scroll down has our define translation function. And this function is incredibly simple. As you can see, all it does is return an array of values and nothing else. So if you don't want to use this define translation function and you don't care about the TypeScript benefits, you can actually inside of your translations, wherever that function would normally be called, just return an array instead, and everything else is going to work entirely the same. You don't get type safety when you define your actual translation, but if we go ahead into our application and we remember what that was my inbox messages, and we go down to our inbox messages, you'll see we still get full type safety here. I get an error if I try to pass in messages with no value, or if I try to pass in a string, you see I get an error. So we still get type safety when we actually use our translations. We just don't get that same type safety when we define our translations. You can see here I'm not getting any type safety at all. And if I leave off this object, you can see I am getting technically an error, but if I leave it completely blank like this, you can see I'm getting no error. So we're missing that type safety. While if I was using the DT version of this, the actual function version, and I just change that over, you'll now notice we get really good type safety. And if I remove this, you can see I actually get an error because it's required that this parameter is passed along because I passed it along in my string up here. So in order to understand how that works, let's actually take a look at this define translation file, because really all the magic is happening in this about 100 lines of TypeScript. And essentially we have a few different types here. We have our parse option type, we have our extract param options, and then we have our param options. For now, I'm going to ignore this param options because this is only there more as like a hack to fit together some of the rest of the parts of our application. It's not actually used inside this file at all. The only 2 things that we have inside of here are our parse option type and our extract param options. And all that this is trying to do is it's trying to take our string. I'll just write out what one of our strings will look like. Actually, I'll just copy it over because it'll be much easier. For example, we'll take this particular string right here and we're going to paste that in. So essentially what we're doing is we're taking this string and we're trying to extract out what all of our parameters are. So anything inside these curly braces, and we're optionally trying to figure out what type it has if it's a typed parameter. For example, the name is a string because it has no parameter, while this date right here, lost login date, we have that typed specifically as a date, or if I wanted, I could type it as a number or a list or an enum, whatever it is. But in our case, this is a date. So to understand this TypeScript code, let me just make my file a little bit larger so we can really see what's going on inside of here. And I even tried to add some comments to make it a little bit easier, but this extract param options takes in a string. So it's essentially going to take in the string, hello name, your last login was last login date. And what we're doing is we're extending this particular type. So by saying that we want to extend this, really all we're doing is we're trying to split our string apart. So we're saying, okay, we have some string that comes before our curly braces. We don't care what it was. It could be an empty string with no value inside of it, or it could be, the text hello, like it is in this particular case. Then we're saying we're matching specifically an opening curly brace, followed by something that we're going to infer as param, followed by a closing curly brace. So you can almost think about this as a regular expression, where we're saying, okay, we have a string, doesn't matter what it is, we just have some text, followed by a curly brace, followed by a grouping in the middle that we're trying to match for. So we're saying, okay, we want to match for this thing, and we're going to rename it to param. So whatever is between the curly braces, we rename to param, and then we have whatever is after our curly braces. So the very first time we call this particular function, essentially we get this value. So the very first thing that we get is going to be hello. That's this string right here, but we don't care about that because we're not matching anything for that. So this essentially just doesn't exist. The next thing we're going to get is whatever is between our curly braces. So we can come in here and that's going to be name in this case. So we get whatever is between our curly braces, and this we call param. So we call that param. Then we're going to get whatever comes after our next curly brace. So that is all of this right here. So that is going to be just like that. And we can again, of course, put this inside of quotes. And this one we are going to be calling rest, just like that. So essentially we're taking this portion of the string and rename it to rest. This portion is going to be named param, and the rest of it we just don't care about. It doesn't matter because it's not a particular parameter. So first we're just checking, does our string meet this particular condition? And if it does, we're going to end up with something like this. But if our string looked something like this, where it's just some text, doesn't matter what a text is, but it doesn't have curly braces, it just says like, hi Kyle, just like that. Well, when we do our check, it's not going to match this particular selector because it doesn't have curly braces. So if it doesn't match this selector, we return the type of unknown because this string has no parameters. I've even labeled it out here. If the string has no parameters, we return unknown. So if we have no curly braces, it just skips down to here, which is unknown. If we do have curly braces, we get to this next line where we essentially do the exact same thing. We're taking our param, which is this particular thing, which is name, and we're checking, does this parameter have a type? Does it have a colon in it? In the case here of last login date, you can see we have a colon. So we're splitting our name and our type apart. So our name would be last login date, and our type here would be date. We're just splitting those two values apart. But if we don't have a colon in there, such as this case where it's just name, you can see that this will fail, which means we'll go down to this case right here, which is calling extract param options, and we're passing in the rest of our string. So essentially we're just recursively calling this type. Extract param options is what we're already inside of, and you can see since it has no parameter type, we don't really care. Essentially, we're not doing anything with this particular value. We're just saying, hey, skip this value because it doesn't have a parameter type, and we don't care about anything that doesn't have parameter types. We only care about things that require us to have type information right now. Now, the reason that we're skipping things that don't have types is because this is for the param options for when we define a translation. And if we go back to where we define our translations, the only time we need to add extra context is when we have, for example, like a pluralization. When we have a date, we may want to specifically define things for the formats of that date. If we have an enum, we obviously need to specify what those enum values are. But if we have a string, we're obviously not doing any formatting on our string because we're just taking the string and pasting it in directly as it is. So that's why we don't need to have extra parameter options for that. These are only the options that configure how our particular code is going to look when we define the translation itself. So if we have no parameters or our parameter doesn't have a type, we just skip it and ignore it. Otherwise, you can see we just call this function and pass in the rest of the string. So now we're taking this second half of the string and passing it back into the exact same function. So in our case, we're going to end up with something that says lost login date, colon date. We're going to get to this section. We're going to split this on the colon. So now we have a name, which is last login date. We have a type, which is date. And now what we're going to do is we're going to pass that into parse option type, which is our other type that we've created. And all we're doing is we're passing in our type and our name. So we're going to pass in date and we're going to pass in last login date. Now, if we scroll up to this param option type, essentially the reason I created two types for this is to make it easier to parse what's going on inside of our code. So inside of here, we're just taking our param type and our param name, like I've mentioned, and we're just checking, is our param type a number? If so, then what I want to do is I want to pass along a parameter for number, and I'm going to say what I want to do is k in param name. All this really does right here is it takes whatever our param name is, in our case last login date, and it uses that as a string. So it's just saying essentially last login date with a question mark at the end. That's all this particular code is allowing us to do right here. It's just a fancy way of essentially taking our param name and using it as a key for our particular thing. And I'm saying, hey, I want to pass in number format options. So if we go ahead and take a look at what that looks like, you can see here I have messages that's a plural. That doesn't actually work. We need something that's a number. So let me just come in here. I'm going to create something that's a number. You can see I'll type in number right there, and immediately I can come down here and now I have options for number. And this is optional because I don't need to pass in parameters if I don't want to. But the nice thing is I can come into here and I can pass in all the different options I want. In my case, my thing is called test. And if I come in here, now you can see I can pass in all my different parameters for customizing what my number looks like. For example, I could say it's going to be a USD currency if I wanted to. But in our case, we don't need that number on there, so I'm going to remove that. But that's kind of what that would look like. That's the type safety that we're getting from doing something like that. So if it's a number, we're just passing in our number format options. If it's plural, it's a little bit more complicated, so we'll skip that one for now. We'll go to date. If it's a date, we take our date format options. If it's a list, we take our list format options. Finally, if it's an enum, we essentially pass in a string to string mapping. So we map from one string to another string. And if we look at what that looks like, you can see here we're taking runner, taking it to the runner text, developer goes to developer. And if we look at our Spanish translations, you can see we have the Spanish translated versions of those words in those particular places. Now, finally, going over to the plural option, the only reason that this is slightly more complicated is because we actually have some required types for this. So first of all, the plural itself is required, just like enum is required down here, but we also have a few additional things. So first of all, what I want to do is I want to take my LDML plural options, or plural rules, sorry, and these are essentially things like one, two, few, other. I can show you exactly what this looks like here. You can see I have one, other, and if I just come in here, you can see we have few, many, two, type, and zero. Type and formatter are additional types I've created myself, but essentially you can see here few, many, two, and zero are all optional, as well as one, but other is required. If we remove other, you can see it's forced to actually pass other in because we need at least some fallback value. And this is just used based on how many things you have. For example, if I have one message, I would say message, while if I had multiple messages, I would say messages. And depending on your different language, you may have different words for few, many, two, zero, and so on. English is rather simple in that you just have one or anything that's not one, but other languages can get much more complex in this regard. So it's just making sure you can pass in different options based on what language you're using. So that's what this first section is doing, is essentially getting all of those values, one, two, few, many, other, and so on. And all it's doing is it's extracting out other because we don't want that to be optional. We want all the rest of them to be optional. And then we're adding in other as a string, as a required string, because we need to have some type of fallback value no matter what. We're also allowing you to optionally pass in a formatter, because if you look here, we're actually taking wherever we put a question mark inside of brackets like this and replacing that with the number. So if you want to be able to format that number to do different things with it, we need to be able to pass in a formatter for that. And finally, we have a type. And this type is kind of interesting because we can actually pass in a type of cardinal or ordinal. If I come in here, you can see we get type safety, cardinal, and ordinal. And really the only difference is this like a number like I have one book, or is it something like I got first place? Depending on that, you may have different numbers. For example, first, second, third, all of those have different context for what you want to type out. For example, if I got second place, that would be 2. So here, when I typed in 2, I would put something like second in this particular place to say that I got second place. So if you want to do a cardinal versus ordinal search, it'll be slightly different which one of these matches you'll get. Because again, if I'm doing a check like did I get first place, second place, third place, 2 would be checked when I have the number 2 passed in. Well, if I'm checking do I have 1 message, 2 messages, or 3 messages, well, obviously other would be hit in the case of 2 because there's no special syntax for using 2 of something inside of English. There may be in other languages, but not specifically in English. So all I'm doing with this entire parse option type is I'm figuring out what is the type of my parameter, and then I'm getting what the options for that are. So do I want to pass in a number formatter? Do I need to pass in some like other parameters, enums, whatever it is? And then I'm just concatenating that onto all the types that we already have. And that's all that this entire set of types does, is it takes my parameters from my string and then determines what values I need to pass for those parameters. And we can actually see this in action by just creating a dummy type we'll call t. And we can call that extract param options, and we can pass in any string we want. For example, we could pass this string in just like this. And now you can see if I hover over t, after I actually make sure my code is correct here, there we go. We hover over t, you can see that my type, it's a little bit hard to read because of the way that the parsing works, but you can see I have an optional date field, and inside of there I have an optional last login date that takes in my date time format options. Now if I were to change name here to be an enum, you'll now see that if I hover over t, you can see I have an enum that's required, that has a name property, which is also required, and that's going to take in essentially an object of strings. And then finally, you can see that that is being concatenated with our date type, so it has both of those different parameters inside of there. So every string that we create, it's going to be able to get this particular options for us. And that's the whole reason why we need to actually have a separate function for this, because that's the only way for us to know what our string is, to be able to tell what our options are. Otherwise, if we just use the array version that I showed you earlier, where instead of calling this function, we just passed in an array, we won't actually get that extra type safety in this particular situation because it doesn't know what the string is when we're actually calling this code. That's why we have this little helper function for that type safety. Now, the next code that I want to talk about is going to be for when we actually initialize and use our translation functions. And this is actually a little bit more TypeScript code. So I'm not going to go quite as in depth into this section because there's a lot of things that are similar, and I'll get into the things that are slightly different. The very first thing I want to talk about is this registered translation section at the very top. This is the thing that hooks up our translations. You can see it's using register and is checking, does register extend translations? Essentially, I want to get the translations property from register, so I'm inferring that as a type of T. So if we again look at our particular code inside of main, you can see I created translations and I passed in the type of all of my different translation code. So inside of here, all I'm doing is I'm saying, hey, what is the type of that thing? If that thing has a type, you can see here, if T extends infer translations, all that means is, does T exist? If T exists, then I want to use that as my type. And if it doesn't, I'm going to be using never. Essentially, this shouldn't ever happen, but I just have the never case in there just to make TypeScript happy. And if we don't have any type for this, if we look at our normal translations here, pull this up, you can see this is empty by default. So by default, if it's empty, we're just going to fall back to using our language messages, which is like the most generic version possible. So we're going to be either using the generic version, or if we pass in a translation, we're going to use the specific version here. That's why we mark this as const, because now TypeScript knows exactly what each one of these different keys are. There are exact value, as you can see here, instead of being typed as a string. And then when we pass that along here, you can see our translations now has a type that is specifically based on strings and so on, and it's not based on anything like a string or anything like that. It's specifically based on actual string values. That's what this particular section of code is doing, is it's making sure that when you as the library user use the code, you get the autocomplete based on your actual translations, and then someone else gets their own translation, while in the library code that I'm myself writing, not the actual user, I'm just using this generic version for everything. Now this language messages is relatively straightforward. It's essentially just a key value. So it's got a key here, which is a string. So essentially an object with any string as a value. And then it's either going to give me a message, which in our case is a string, or the return type of my defined translation, which in our case is an array, as we've already looked at that function, or it's going to return to me essentially more language messages. And that's just to support the ability to nest things. For example, I have this nested type here, which has nested greetings. I want to be able to support nesting different keys inside of each other for organization purposes. So that's all that particular code is doing, is this just allows us to do nesting inside of each other. And then we can return either our string, which in our case, for example, here we return a string, or we return whatever this function returns. Those are essentially the only two things that can be a message. Now we'll skip a little bit further down here and we'll come back to some of this in a little bit, but we want to take a look at the actual function itself, because this particular function essentially just takes in our string. So that's pretty straightforward. It takes in essentially all of our translations. So we have our language messages mapped to particular strings. I specifically made sure that these are lowercase strings. And if we go ahead into our actual file and we try to change these to uppercase, for example, I tried to make this uppercase, you can see I get an error. The main reason I did that is to make sure that when I do my matching, I always match to the specific value I want. So making sure this is lowercase will make sure that mapping works properly. Then I'm doing some code to get my fallback locales. So here I'm just checking, is it an array? If so, use it. Otherwise, put the value in an array. That's just to make sure I can support passing one value or multiple values. And then this is kind of the magic for how everything works for getting the correct fallbacks and everything, is by calling this ordered locales. So essentially I'm just creating an array of locales that are ordered in order from which one I should check first, second, third, all the way to the very last one that I should check. So we can go into this function, which is get locale and parent locales in the correct order. This function, all it does is it takes in a locale string. And what I want to do is I just want to check this string and constantly cut off the parts that are more and more specific. So if I pass in the string en.us, I want this function to return to me an array that has en.us as the first value, and then en as the second value, because this is a less specific version of en.us. And if it got even more complicated, for example, I had another value on here, it would just add that onto the top. So I had en.us.ca, just like that. So that's kind of what I want this function to return. And that's all it does. All it does is it takes my current locale. If I still have information in my locale, I push it into the array. And then after I push it into the array, essentially I'm taking all of the content that comes after the dash. That's all this code is doing. Is it's saying check from the end of the string, get all of the content that's not a dash, and replace it with an empty string. So I'm essentially taking everything that's not a dash, as well as the dash itself, which is this code right here, replacing it with an empty string. So now essentially the first time I call this, I'll have en.us.ca. The second time I call it, it'll be reduced to en.us, and then finally en. And then lastly, I'll just get an empty string back, and we'll know that we're done, and we can return our locales back to us. So this is getting us those locales in order. And what I'm doing is I'm first getting my locales in order based on my current locale, and then I'm going through all my fallbacks and doing the exact same thing. Finally, we get to where all the TypeScript magic happens, which is inside of this function T. And this is actually a function with 3 separate overloads. Well, 2 overloads and then the generic version itself. We first have what happens when we try to pass in a path with no params. For example, if we look at our translation for locale or greeting, you can see, well, actually greeting has parameters, but you can see here locale has no parameters at all. Same thing, missing ES has no parameters at all. So it needs to essentially take a different TypeScript type than the one that does require parameters. Here you can see path with parameters takes in this arguments key as well for all the different parameters that we can pass in. Then down here, we have the actual definition for all of this. And most of the code inside here is not too crazy complicated. I'll go over it real quickly. Essentially, we're just looping through all of our locales in order. We're getting the translation file. If we don't have a translation file, we skip this and go to the next one. So for example, if we check ENUS, we don't have an ENUS file, we go down to EN, and if we don't have that, we'll go to the next fallback until we find something that actually works. Then the next thing we do is we call get translation. All that does is it takes in our translation file as well as the key and all of our different arguments, and it's going to return to us undefined if it can't find a translation. For example, in this case, our ENUS is missing lots of translations. This one has some missing translations. So if it's missing a translation, it returns undefined. Otherwise, it returns to us the translated string with all the substitutions made, and we just return that value if it's found. Otherwise, if we don't find anything at all, we just return whatever the key we passed in is. So in our case, if I were to just type in a bogus key, we're going to get a TypeScript error, but you'll see if I give this a save, it's just printing out whatever key I passed in. It doesn't matter what this key is, it's just going to print that out over to the screen over here, as you can see. So we either pass in the bogus string that we pass in, or we actually return the specific value that is being translated to. Now we'll dive into this function a little bit, but first of all, I want to go through some of these types to figure out what these different types do, because we have this .pass4 type, as well as these path with no params, path with params, and params type. So let's dive into this .pass4, because this one is relatively simple to actually understand what's going on. The code is maybe not super simple, but what's happening is really not too complex. So .pass4, all it's doing is it's taking our translations. You can see we have our registered translations. That's either the generic version or the specific version. And it's just essentially looping through all of our different keys. It's saying, hey, is this the particular message we're looking for? So if we're already at the lowest level where it just returns to us a string or an array, then we know we're at the correct location. We're going to return whatever k is, whatever that particular value is. Otherwise, what we're going to do is we're going to get the value inside that object. So we're saying, hey, does this thing extend an object instead? If it does, then that means we have nesting to worry about. And we're going to call this join function by taking whatever my current key is and whatever the object that is the child of that key. And all this join function does is it combines the two keys together. So let's say that I had an object that looked something like this. Let's just copy this over and we'll take a simpler version of this. So we'll just paste this in here. I'll comment this all out. There we go. So we have this rather simple object here, and I'm just going to get rid of pretty much everything except for a really simple string. There we go. And then we're going to have our nesting. So these are our only two values that we're going to worry about. So if we call .pass4, it's going to take in this particular object. It's going to loop through each key. That's what this k in key of t does. The first time it's going to give us hobby, and it's going to give us the value here. So you can see here we're checking, does the value at that key, which is this string right here, extend an I18 message? It does, because it's just a string. So if so, we just return k. So we're just returning hobby as our very first value. Second time we go in and we get nested. Nested does not extend the value here. It's an object, so it doesn't extend this, but it does extend object. So we're going to call join with nested and passing in whatever the object is right here. So that is going to return to us essentially nested dot greetings, just like that. And then it's going to call .pass4 with greetings. As you can see, greetings here has a string as a value, so it's just going to return k, which is just going to essentially return this. And we're going to end up with a type that looks like this, where it's hobby or nested.greetings. So all it really does is it takes an object and it turns it into the dot notation to get to all the different values inside of our object. So that's what this type does, as well as this join type. So we've covered all the types at the very top here. The next thing that we need to worry about here is this enum map. This is really just a helper type. It doesn't really do anything. It just saves me from typing this code over and over again. Essentially, anytime we have enums inside of our code for our actual parameters, it's defined as a string that has a record string inside of it. So it's just an object which contains an object inside of it. It's just the boilerplate enum value that I use in a few places. So it's just there to prevent me from having to type out the same code over and over again. Next thing I want to talk about is this extract param args as well as parse arg type. You'll look at this code and probably think it looks very familiar, and that's because it's nearly identical to what we did here for our defined translation. It's the exact same thing, but instead of getting our translation definition parameters, this is actually going to get us for when we call the actual translation. So inside of our code here, for example, where I have my translations being defined, this tells us what the type of this second object should be. So again, all I'm doing is I'm looping through here. I'm checking, I want to get my parameter, then I want to check what the type of that parameter is, and then I'm going to parse out my argument type specifically for those parameters. And this parse arg type, you can see here, if I type in number or plural, it expects a number, date expects a date, list expects an array of strings, enum expects my enum to be in one of the values in my enum list, and so on. Relatively straightforward what's going inside of here. It's the same thing we did in defined translation, so I'm not going to dive too deep into this particular code. The next type down here is this translation at key with params. All that this type does is essentially take our dot notation, unwrap it and figure out what the value in our object is supposed to be for that particular section. So again, if we had an object that looked like, nested, and then we had an object inside of here, something like that, and we passed in the dot notation of nested.greetings, what this particular type right here would do is return us the type of where that is inside of our object. So it just unwraps our dot notation into something we can use inside of our code. Same thing here, this normalized translation at key is again essentially making sure that when we have our things being returned, sometimes we have an array, sometimes we have a string. This is just normalizing it so we always return an array instead of an array or a string. Finally, if we scroll down just a little bit further here, you can see we have our params, our pass with params, and our pass with no params. And all that this is doing is essentially just getting all of our parameter-based information to be used inside of our function. So it's just taking what we figured out from all of this code up here where we figure out what our params are and what they're supposed to be. And all it's doing is it's massaging that to make it work specifically inside of our code. And so you can see here is essentially just making sure we return what our enums are for enum related stuff and so on. It's overall not doing a lot of complicated code. And then in the case here, if we have a path with params or a path without params, this is just splitting our different items because, for example, inside of my code, if I have a section where I want to define, for example, locale, this does not have any parameters, I want it to throw an error if I try to push an object into here. And you can see this is throwing an error because this is a path with no params. While if I try to not pass any parameters into something that requires them, you can see I'll also get an error if I try to do that. So it's the only reason I'm splitting these values between the two is just to make sure I get errors based on if I pass the value or if I don't pass the value in. So that's all of our different type information. I know it looks really confusing, but it's each just kind of solving simple steps inside of our system using rather complicated TypeScript code. And the last thing I want to kind of look at is the actual code for getting our translation information. The main bulk of that code happens inside of get translation. We pass in the locale we want to translate for. We pass in all of the translations for that locale. We pass in our key, which is going to be that dot path notation, as well as all the arguments for that particular key. First of all, we're going to get the translation by key, and all this does is again unwrap that dot notation. So we start with dot notation, we're going to split this, and essentially we're just looping through our value in our objects and constantly trying to get down and wrap whatever our dot notation in. So if we pass in nested.greetings, it'll give us the object at the nested greetings section inside of our object. Relatively straightforward what's going on there. Now, once we have that actual translation, this is going to be whatever we defined in our essentially translation file. So this is either going to be a string that looks like this, or it's going to be an array that's going to have essentially a return value with a string and with some arguments afterwards. So you can see if we scroll down here, if the type of our translation is equal to a string, that means we don't have any additional parameters or anything like that. So we're going to pass along an empty object for our additional parameters that we define when we define our translation. So essentially this section is blank, so we're just going to pass along a blank object in that case. Otherwise, if we have an array, then what we're going to do is we're going to make sure we break apart our string and our params and pass those along into this perform substitution function. Finally, if there's an error anywhere inside of here, I'm catching that because I'm throwing errors in these functions for particular malformed code, and otherwise, again, I'm returning undefined if it doesn't find anything. So the last function we really have to look at to figure out what this get translation does is the perform substitution. It again takes in a locale, it takes in the string that we want to do the substitution on, which is like this string right here. It's going to take in all of our different arguments. Those are the things that we pass in this particular section of our code when we define, or not when we define, but when we use our translation. And finally, it takes in our translation params, and that is what we create when we define our translation. So here, that's what this particular object is doing right there. So then all this code does is it takes my arguments and it's looping through each one of my different arguments and it's reducing them down to one particular string. So if our arguments would be like name, Kyle, and so on, if we look at our code, for an example, this one would have a name of Kyle and a last login date of new date. So we're looping through this. So in our case, we would have name Kyle. And then the second time we loop through, we would have last login date and new date. And what we're doing inside of here is we're trying to match our parameters inside of our code. So you can see here, we have our curly braces. So we're getting code between those curly braces that have the key for our argument. So the name, or this would be last login date. And then we have an optional section here, which is saying optionally, do we have a type for this as well? So this match is going to return to us essentially the place where we want to replace our code, as well as optionally if we have a type. So if we have a match in this particular case, then we're just fine returning whatever we have. For example, that would mean that we have a name and we have some type information. But if this didn't match, then that means that we don't actually have any type information. So you can see here, I'm instead just replacing this with the curly bracket version with no type information, and then I'm returning undefined here. So either we get the type information or we don't get the type information. So this will either be undefined or it will be a string, as you can see. Then what we're doing is we're just, for each one of our different cases, we're doing our replacement that we need to do. So in default, the case where we don't have a type being defined, we just come down here and do a simple replacement. We just take whatever our argument value is, and we're going to replace it with whatever our replacement key is, which in our case is just going to be that place inside of the curly brackets. So if we look at the English one here, for example, hello name, your last login date was whatever, you can see it's going to replace these curly brackets with name with whatever you pass in as the name parameter. So to replace that with Kyle, and we can even see that over here, it says hello and then Kyle. Next, what we're going to do is go through each one of our different types. So for example, we'll do plural last and enum last because they're the most complicated. We'll look at number. First of all, we're making sure that we pass in a number as the value that we want to do. Then what we're doing is we're creating a new number format. And actually, there's something that I'm missing inside of here. I should be using the value from our number format that we pass in. A better example is right here. I'll just copy this up and paste it down because that'll give us the exact same thing, but this should say number. There we go. So what I'm doing inside of here is first get my arg value, then I check my translation params to see, hey, did they pass in some parameters for this to be used inside of our code? So if we wanted to test what this would look like, I can come in here, wherever I use a number one, looks like I don't have any with number, but I can come in and just add number to this one, just like that. And then I could pass in some number parameters. And again, for example, I could pass it in saying I wanted to have a currency of USD, and now whatever number I pass in will be formatted as a USD currency, and I could change this, do whatever type of currency I want, but now I can change how that number is being formatted. So if I pass in some format options, I want to use them. Otherwise, if I don't pass them in, I'm just not going to use them, and I'll use the default formatter options. So that's all that this code is doing, is creating my formatter, and then I just run the formatter passing in the value. And that's how it works for our number. That's how it works for our list. You can see the same thing. We have the list format, pass in those parameters, and then format, and same thing with date. We have our date time format, pass in our parameters for our options, and then use the actual format function. And that's what's really cool about JavaScript. Date time formatting, list formatting, number formatting, plural formatting, even relative date and time formatting is all built into JavaScript with localization for every locale you could ever think of, and it's perfectly functional, which is something that I absolutely love. A great example of this is if we look over here, you can see my date right now says May 19th, and this is inside of the format of like the US format for dates. If I change to Spanish, you can now see it says 19.5 because that is how you would format May 19th inside of pretty much every other country that's not the US. And that's not something I had to hard code inside of my format. This is something built into the JavaScript date time formatter. So I really love using these different internationalization formatters because they're really, really powerful. Now let's minimize these down because really we don't need to worry about any of these. The last two we have left are plural and enum. Enum is again relatively straightforward. First, I'm just getting my argument value. I'm checking my enum map, so I'm getting my enum map, and I'm getting the value from that map for my replacement. If for some reason there's a missing replacement, I'll throw an error. Otherwise, I just take the replacement and replace it with the key. Again, if we look here, you can see I defined my values as runner and developer and developer. And when I actually use this code, you can see my hobby is passing in runner. So I take this string runner and I look inside of my code. We'll look at the Spanish one. I see where runner is. I get the text for that and I paste that wherever this hobby section is. That's all that little bit of code is doing. It's just getting the value and pasting it into here. So that's relatively straightforward. Then we can move on to plural. And this one's the most complex, but it's really because it's like a two-step process. If we take a look here, the very first thing that we're going to do is we're going to get our plural map. This is whatever object we pass in when we define our translation. So you can see here it's messages with our one and other value. Then we're going to get the type from this because we can pass in a type of either cardinal or ordinal. So we want to make sure we're using that specific type in our plural rules. Now, when we get our plural rules, that allows us to call this select function. And by calling this select function, it's going to return to us something like one, other, zero, two, many, and so on. All the exact same keys that we defined on this particular object here. And what we're doing is we're just checking, hey, with my plural map, I want to get a key for that value. If I don't have a value defined for that, for example, if it returns 2, and in my code, you can see here I didn't define anything for 2, it instead falls back to the other value by default. So that gives me my replacement text. If I have no replacement text, throw an error, but this should never happen with our TypeScript formatter set in place. Then we're going to create a number formatter. And the number formatter uses the formatter key on here because I could pass in a formatter with all of my different number formatting that I want to do. And this is to replace essentially anything that has a question mark, such as this question mark here, with the particular number that we passed in. So again, if I go back to this code, I'm getting my number formatter, I'm replacing my question mark sections with my formatted number, and I'm replacing my replacement key with whatever I get from my number format replacer. And if we look at our code here, you can see you have 3 messages is returning to us correctly. If we look over here, you can see question mark section is being replaced with the text of 3. And if I change this to be only one message, here I change messages to one, you can see it says the text one message instead of messages instead. And that sums up everything to create your own internationalization system entirely from scratch. And if you want to see other videos like this where I build systems like authentication, permissions, feature flags, accessibility, and so much more from scratch, I'm going to link those right over here. And with that said, thank you very much for watching and have a good day.